Hello everyone, welcome to my shop. I'm Robin. And what have we here? Looks like a renzometer, straightness and repeat reading gauge. Lots of unidirectional carbon fiber. Some fancy flexures going on here. Looks like some kind of loading system for loading the feet for two different directions. Kind of looks like a half bridge LVDT from a 599-981 Brown and Sharp lever gauge head, like that one. Maybe some feet being lapped. You can see the reflection there in the feet. Those are getting matched height within a few micro inches of each other, and feeding into a 599-1021 electronic indicator at 1/1,000th per division. That's a pretty smoke and repeat reading gauge, and it'll be able to measure straightness without a reference, self-calibrating. But that's not what this video is about. Sorry. This video is going to be on a much more boring topic, and that is a method of making parts like this out of plastic that have thin cross sections, very difficult to be able to grip and hold, just not your typical part. And I'm going to show you a very easy method to make these that makes what could be a real nightmare into something that's relatively easy. These pieces are made out of PET, which is similar in machining to Delrin. I actually like it a little bit better. It's sort of a little harder, crisper version of Delrin, and machines very nicely, similar, but it doesn't have the smell that Delrin can have if your cutting tools get warm and generate some, I think it's sort of like a formaldehyde smell. PET doesn't have that at all, but mechanical properties wise, PET is in same general ballpark and same general price range. So if you've never experimented with PET, you should give it a try. It's a very nice machining plastic. So this method is to chuck a whole bar long as you can reasonably handle. In this case, I cut a 12-inch length of this material in half and grabbed the full 6-inch length, and you'll see me hanging out of the chuck and doing this. And it's a situation where I use the programmable digital readout to do a pitch of these. I basically take the full length of the part, pick out a groove tool that I'm going to use to part in between them, and I'll turn the OD contour on all of them with the program where it steps down and does a repeat of these all the way down, and then I go in and groove in between them, and then I use a groove tool and a tray painting style groove tool and come in and cut underneath these and part them off complete. And in the process, every time there's an opportunity to be able to chamfer edges or whatever while it's rotating, I'll do that. And then finally we'll take these pieces and push them onto a little arbor just manually and hand chamfer the last edge that wasn't accessible on each of them with a ceramic scraper. So that's the general technique. And if we look at this particular part, this thing isn't really anything crazy. There's not super tight tolerances, but it's a scrawny part. These things are roughly 3 inches in diameter, barely an eighth wall here, but they've got a little contour here. They've got a little bevel, 15 degrees, and a nose, and basically the turning tool does the whole distance, comes out, turns this, and then I go past and use the back of the tool, the angle on the tool, to do the chamfer, and then carry on and do each one after that, and then groove tool, as you'll see in the video. So that's the technique, and that's what all of the footage in this video is on. But this technique can be applied to other things that I make in a very similar fashion. And here I have a seal ring that I do. All these parts are parts that I designed. I designed the machine, the machine tool piece that these go on. And this is a face seal. and has a groove in it. And we'll show you the actual cross section of this. This is very, very small. You'll see here the dimensions, dimension-wise. This thing's only like 86 thousandths wide. Here has a groove in here that it gets a piece of a Viton O-ring stock to load it. And these I actually changed to, this says 60 on the drawing, I changed them to 45. And so this part is really tiny, really thin wall thicknesses and everything. Would really be a nightmare to do any other method. And in this particular case, I use a technique where I was brainstorming how to do these. I have a little tool right here in carbide that you can see that has this on, and I come in between these with this carbide tool and plunge down in between, clean the groove out, and then I'll come down at a certain distance, move over, clean that wall, and generate this sharp corner. Move over, do the same thing here, move over, go down like that. And I'll do all that before this groove is in, because I need support that the plastic doesn't flex. Even though these tools are very sharp, you still get some push, and you get chip wrapping and all kinds of things. So this is done at a particular pitch. You'll see I've got that 0.177 there, and that's the pitch of these that I do. So I'll stick a piece of 4-inch. These are like 4 inches in diameter. I'll stick a piece of 4-inch material in the chuck, hanging out a lot, probably a good 8 inches worth, and I'll literally go down and do each of these operations with a program on the programmable digital readout, where I'll go in and do this pattern, bump, 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 move over, bump, 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 all the way down, to do that particular feature all the way down. Obviously, in first operation was to turn the OD to the right diameter, and then I'll come back, do the groove in the center with another groove tool that does this groove after this groove is done. And then I'll come underneath and I'll use the same technique you're going to see, where I use a facial tray painting tool to come in and cut underneath these and release the finished part. So that's another part that I do that technique on. And another one is an actual lip seal here. And this style right here, this is up on the opposite side of where I actually turn it. But I use a tool like this. And this back edge here goes in and does the actual underside here. It comes in, and I'll flip the tool upside down. It comes in and does that. And then this top edge does the other. Actually, I'm going to come down to where I have the small cross section here and show you what I'm talking about here. So this tool comes in and actually turns, this gets rid of all the excess material. You notice this is where this can pass the material that's left. Come in here, programmatically come in, bump in to form that entire angle, come out, come over, go in, and it does that whole groove shape right there. Come off, the OD's already been turned. Then I just do a chamfer down the whole stack of them. The chamfer's already in there. And then just part it off and then move down to the next one. So this operation here keeps turning the center bar down to a new diameter. And you're left with a big chunk of stock that's still usable. You're only using this outer perimeter of the stock. That's whatever radial thickness you can get this all done in. So just think of this technique, and obviously without a programmable digital readout, it's going to be more cumbersome. And when I say programmable digital readout, I'm talking like an ND 780 or 880 Heidenhain, or the old PT 855 is the one that you've seen me use. Just a fantastic readout, and allows you to do stuff on a manual lathe that just wouldn't be that convenient. So just wanted to give you a background on what this is all about. You're going to see all the techniques on here. In the particular case of this video, I'm going to show you the other operations involved in putting the holes, 3 holes in this. This is actually a cage that holds 3 ball bearings in place on a actuator, and you'll get to see that. So let's get on with the rest of the video. Here I'm cleaning off the spindle nose of the Harding, blowing out the key, wiping it off, make sure it's absolutely clean, looking at the chuck, making sure I know where the pin is. It's already been cleaned, putting it on gently, not smacking it to the back, just gently putting it in, putting the lock in the spindle, and then just a gentle nudge to tighten it up in the direction it's going to get loaded. Putting a piece in the 6-jaw chuck, Can't beat the 6-jaw for holding on to things well. Getting an indicator, don't really need to indicate this. I don't even know why I put this in the video, but you can see indicating in, just not getting in a little bit closer than it was, but totally unnecessary because the whole OD is being turned. Here I'm adjusting center height of the tools. You'll notice I have a special wrench that fits into the threaded clamp collars. Replaced all my tool holders with those clamp collars. Makes adjusting center height really nice. The threads have been lapped on the set screws so that there's nice, even, uniform drag. Just setting the height, there's the tray panning tool, the face tray panning tool that will go in and cut the parts off of the main body. And just setting that height with a scale. Facing off the part, setting Z0 of my main turning tool that does the OD and the shape. Turning a diameter so that I can set my X value, measure it with the calipers, punch that into the digital for that particular tool offset so it knows exactly where it's cutting. Groove tool now, setting Z, touching the face, turning an OD with it also to set the X diameter, punching that into the digital for that tool number. Measuring the tool width here on that tray painting tool to add 2 times that width to the diameter that it turns because I'm driving the ID cut of that. Here you can see the back relief on the tray painting tool in both directions so that it doesn't rub. It only cuts on the face, leaves no space there. And cutting the OD with that and then setting it with the calipers, entering that into the digital. Now I'm actually running the program with the OD turning tool, going through the sequence on the Positip 855 Heidenhain, and that allows me to follow an exact pattern, do exact moves, and you'll see what I'm doing on the actual readout here shortly. Right there's the screen. You can see the step numbers up on top and it tells what that step is actually telling me to do. And I just follow along. You'll see the position indicator bar at the bottom. You'll see on the bottom there, we'll see how that comes up in the little box. That really lets you nail these things at high speed as you're doing these. And this isn't a super precise part, so you see I'm not worried about hitting things dead nuts on here. The readout's in 50 millionths on diameter and on Z position, so it's pretty fine increments you're seeing there. And this thing is hard to video without the glare on there, but that's the best shot I could get. So you're just following along, doing each individual move, and it's just really nice. And it'll hold 20 different programs, and there's looping in here. I'm using incremental moves to be able to do these patterns on the OD, and this was just the pattern for the actual OD turning. Here doing the same pattern arrangement, but this is with the groove tool, and we're going in and doing the incremental moves. You're seeing the readout on the Positip there, where I'm just going in and doing the actual axial position in on X to get below a certain amount, and then back out on X, and then move in Z again. And yeah, this is very, very quick. And that's also one of the reasons that you need the rigid tool post. Because you can't have these things moving around as you're changing tools. You need it to be very accurate. Now I'll be hand deburring these. That's just a X-Acto number 11 blade with the edges ground square and just doing a nice scrape at a slow speed. Deburring all the edges while it's easy to do here with the parts spinning. And I'll show you here when we get to the end here. I'll show you a little close-up of what the blade looks like. Just needs a dead sharp square edge cut. And then this is 4.0 steel wool, which does an excellent job of removing the fur that you can get on plastic. Now we're using the face tray panning tool to go in and I do a little bit so I can chamfer the edge, and then it'll go in and cut all the way through. And this is how we get to take these parts off in basically complete and still end up with all this material left in the center. And we also are not, we have basically no chuck loss, chuck grabbing material loss on these parts, because you'll see we're going to end up turning this around and grabbing it on that other diameter. And the only loss we have here is the actual width of the parting tool that we use to go between the pieces. Now we're just moving back
doing the pieces all the way back to the last piece that I was grabbing here. This was a 6-inch long piece that was hanging out there, and I'm only showing doing 1/2, but I'll repeat this on the second 6-inch long piece on the other half. So there all the parts are, flipping the piece around, grabbing it again, and I'll put the turning tool back in. Now I'm going to do a datum shift on the digital, which shifts all of the tools with it. So it's kind of like a G54, G55 type thing on a CNC, where I can move all the tools relative to each other down to the new position, and then face this off, and all my other tools that I've been dropping on and off here are all still in sync in the Z, and obviously in the X hasn't changed. So just doing my facing cut there on the end, and then we'll go back, just run the same program again that's doing the ODs, and that program basically loops forever. The way I wrote the program, it wouldn't matter how many pieces I had, it just keeps incrementally going down with a little loop in the program to do the OD turning on there. So now we're going to do the same grooving pattern like we did before, and basically we're just completing all the parts possible on this first blank, popping off the rings, doing the chamfer, grooving in, and that's the way it works. And like I showed you in the beginning, there's all different types of parts that this method will work on, and you're left with a real nice piece of valuable material there in the end, instead of just total loss. And now I'm putting on, and I'm just using a Noga ceramic blade, and that plug is actually a fixture I use to do the 3 ball holes that go in this, which you'll see later. And I just push them on there gently to be able to chamfer the one edge that was where it was the tray painting tool cut.
So I have my Harding indexer in here. One thing I did long ago was to grind the flats on both sides of this that are aligned with the key and perpendicular to the bottom. This just makes the setup so much quicker. I just hate taking vices off. I basically never take them off. I work my way around it, and so yeah, this really helps. I have a backing plate bolted on here that lets me grab this thing vertically over in the DPM. DPM's got a huge amount of Z-axis travel, so I can stick this thing in the vise, put a chuck on here, and still have plenty of room to drill. Here I'm indicating in the center line of the indexing head to be aligned with the center line of the spindle. So I've got a 0 back here. I'm actually indicating this is tapered, but that doesn't keep you from getting an accurate center. So I'm zeroed back there. Now if you watch, the needle will climb as it's climbing up over the corner. When you do this, you have to make sure you're not too far engaged, where that causes you to peg the indicator and bump your setting. So you can see there we got the same 0. See the climb right there? But it's well within the stroke of the indicator. That's the one thing you got to watch for. The other thing is, it's not actually important for this, but you also typically want to find your peak vertically, so you're right on the peak of your reading there, but it's actually not essential for aligning in this direction. Masking the holes for my 3-hole index on this, so just indexing until I get to the 3 location. I'll leave that one out because I had that one set. I was doing I believe 12 before with this, so I've got to crank in all the the masking set screws from the back here to get to where we're only doing the 3 divisions, which is what we need. It stays. And there's 0. So we got 0, 3, 3, back to 0. We're good to go. Gonna mount the chuck on here. Got our 4-degree nose, nice and clean. Feeling here for any chips, dirt, whatever. Line our index pin up. Slide on. I always like to go the normal lathe direction so I know which way to go to loosen it, because you can go in either direction. That's it. So these fit a little more snug than before, so I wasn't able to pull that off with my fingers. So I added flats on the back of the chuck here that line up with the vice jaws so that I can just give this a pop once I'm done. So as you saw there, that wasn't much help. But here's one of the beauties of the taper lock nose. I can take this thing out right now, and let me put this over where I can get at it a little better. There we go. I can take this off. This is about 5 thousandths oversized. I don't know whether it's from the part swelling, from moisture absorption from a long time or what, but I'm going to just pop this off, go over in the lathe, trim this down, and bring it back. That's one of the beauties of the taper lock system here. I'm not losing a thing. Back at the lathe. Take my chuck out. Drop this on. That's that. Put my turning tool in. I don't have to measure because I know what this tool is going to turn because of the tool post system. Set my tool 12, X 2.774, enter. Simple as that. Pop this off. Back in the middle. Back on the mill, on the indexer. Snug this a little bit. Make sure our index is still good here. It doesn't have to be super precise. It'll just mill a little bit bigger. I just don't want to turn it into Swiss cheese. Now, oh yeah, that's better. More like what we're hoping for here. using an X-Acto knife with just the back edge ground off square to act as a scraper. So I'm using this actual back edge, this square corner, for my scraping. So on these I'm just going around and doing a full loop to do the OD. Tough to keep this in camera while I'm doing this. Taking a full lap around these. I think I did that one already. Then on the inside I go half and half. I go half one around all three and flip it. That's it. Well, I hope you found something useful or interesting in that video. If you did, please subscribe, share, comment, thumbs up, tell your friends, and please come back next time when I probably will be covering some more details on the Renzometer. That name came from a suggestion on Instagram from one of the followers, and kind of stuck. And the repeato-stratometer has too many negative connotations possible, and trademark and name problems involved, so that's why we moved away from the repeato-stratometer to the Renzometer. So hope to see you next time.